So far in our tour of the Android API, we've talked a lot about the functionality of things like activities and services. This is an important part of your application, but it's not what your user sees. Now we're going to talk about how you build user interfaces in Android. Now when it comes down to it, the visual aspects of a user interface, the widgets that the user interacts with, are represented as objects, just like any other object in your Android program, whether it be a domain class or whether it be a Android object like an intent or an activity. There is a class hierarchy of user interface widgets. There are two fundamental base classes. There's a class called View that represents a UI widget. This is something the user can interact with, see, things like buttons and text fields, those good stuff. And there's a special kind of view called a view group. This is a view that is actually made up of multiple views objects that are responsible for laying out those child views. So a view group will do things like arrange the objects horizontally next to each other. So UI objects maintain state, and that state is available as properties with getters and setters that can be accessed and get and set from the application. So for instance, the text field UI object, you can get the text that was entered, or if you have a slider bar, you can say how far along the bar the slider currently is. Those kinds of things. In Android development, there are two primary means by which UI objects can be created. You can create objects directly in the source code. So for instance, on the onCreate method of an activity, you can create new objects, you can set their state, glue them all together with view groups. That works just fine. But the preferred method is to declare the UI objects inside XML files. This is preferred because it separates the UI layout from the logic that interacts with the UI and handles things like the user entering text and the user clicking buttons. Also, by abstracting the declaration configuration of the UI layout away from the business logic, if you will, of your application, it makes it easier to provide different layouts for different devices or screen configurations. More so than desktop applications or web applications, it's important that small device applications work well on a variety of differently sized devices. Your same application might run on a very small cell phone through a larger tablet, or even on something like a large screen device. Here's a visualization of some of the classes in the View class hierarchy. They're in the Android.View and Android.Widget packages. At the top of the hierarchy is the View class, and it has a class hierarchy that we'll talk about now. And we'll talk about things like view groups and text views and buttons. So View is the most abstract class in the UI widget class hierarchy, and it basically represents a rectangular portion of the screen. As you go further down the class hierarchy, you get more and more specific UI controls that do things like display text and images and support user interaction. Views have properties that configure how the widget is displayed, everything from the text displayed in text widget to colors and things like that. User action with the widgets is responded to via what are called listener objects that are registered on the widget, and we'll see examples of that later. Now, while each view object has things like a height and a width, those usually aren't set directly by the application developer. Instead, a view group object is used to lay things out according to some algorithm to make sure that it looks intuitive and easy to use. Similarly, the look and feel of a widget, its colors, the fonts that it uses, is determined by its theme. So applications ought to have a consistent theme, and the theme of an individual widget is almost always inherited from its parent widget and its layout. While the Android platform itself supports themes, each Android device or maybe device manufacturer will provide its own theme so the user knows that they are working with a device from a particular manufacturer. Very often you'll want to associate an ID with your widget. This allows that widget to be easily located so that you can interact with it. You can also associate other information with a view via the tag property. And all views support tooltip text to provide a hint about what the widget does. Text view represents text that is displayed to the user. There's a number of properties they can set on text views. Obviously, the text will be displayed, whether or not the text represents a number, whether or not it's editable. Text views can have a hint, which is text that's displayed when there is no text yet. This is a prompt for the user to enter some information. And also the number of lines in the text view. So you can have a multi-line text widget. By default, it's a single line. If you set the password, then the text that's drawn in the text view is a password, and so it won't be shown to the user. There's a subclass of text view called edit text that allows text to be edited. Text view supports multiple formats of text that are determined by the input type. So for instance, you can have an input type that represents a phone number, or a date time, or a number, or an email address. This is also how you can configure autocorrect and whether or not you want words to be capitalized. There's another text view called autocomplete text view that uses an object called an adapter to provide suggested values for the text being entered. There's also a text view called text clock, which displays the current time as text. A button is a type of text view that responds to a user clicking on it, or in the case of most devices, tapping on it. There are several types of buttons. Compound button is a button that can have a checked or unchecked state, such as a checkbox, which just has a checked attribute and a toggle method. So your application can toggle the checkbox using the toggle method, and of course the user can also tap the checkbox to toggle its state. Radio button represents one of several buttons in a radio group, only one of which can be checked at any given time. And then there's switch and toggle button, which are widgets that lets the user visually slide between two options, like a light switch. These buttons have two text states, the on text and the off text. And then as the user slides, that'll determine which text is displayed. You may also want to investigate the checked text view if you have a list of text items where the user can select multiple. Images are rendered inside Android applications using the Image View widget. The source of the image is an object that implements drawable and is specified by the source attribute of image. There's a wide range of different drawables. You can have everything from a bitmap to generic shapes to animations. Not surprisingly, Android supports many different kinds of images from many different kinds of sources. If you've got static images that come from files, those reside in the res or for resource/drawable directory. Two subclasses of image view are image button that acts like a button but contains an image instead of text. This allows you to use different images for different button states. There's also an image view called Quick Contact Badge, which shows the image of one of your contacts based on their phone number or email. There's a type of view called Web View, which displays a web page, HTML. This is not intended to be a fully fledged web browser, and it doesn't have things like navigation controls or a URL bar. But if you've got some static content that's hosted on the web, it's a really good solution, right? Things like for your license file or just sort of static information, an about page, things like that, WebView is just great for. Now note that in order to use a web view, applications must have the internet permission. So web views can load an HTML URL using the load URL method, but it can also load data as raw HTML from a string. So maybe you've got something stored locally, or maybe your application generates some HTML. You could use load data to view that in WebView. WebView does have support for JavaScript in the browser, and you can have that JavaScript interact with objects from your Android application by invoking the Add JavaScript Interfaces method. If your HTML contains hyperlinks, you can enable following them by overriding should override URL loading method. And while the user can't navigate back and forth, your application can do so by invoking the go back and go forward method. Again, WebView is meant for simple HTML and not a fully fledged web application. If you want to go from your Android app to a more complex web user experience, then you should launch a web browser using an intent. So those are some of the widgets. Now I want to talk about the view group. And again, a view group is an object that lays out other widgets according to some algorithm. This diagram depicts the class hierarchy for view groups. As you can see, there are a lot of them. Views are rectangular, and their position is determined by their left and top properties. That says where they are on the screen. The values of those properties are relative to the widget's parent component. When talking about the size of a widget, there are two different concepts. There's something called the measured width and height, which is the preferred dimensions of the widget within its parent. So this is how much space it would like to take up. So for instance, if you've got a text view and you want to display some text in it, depending on that text and other properties such as the font size, the text widget will have an idea of here's how large I want to be. The drawing width and height, and these are the values that are available via the width and height properties, those are the widget's actual dimensions when it's laid out on the screen. The drawing width and height are a floating point number that's measured in the number of pixels or density independent pixels. There's other things like scale pixels and also just plain old millimeters they can use for specifying these heights. You can also use a couple of shortcuts when specifying the width and height of a widget. There's something called match parent, which says be as big as the parent minus the padding. So basically take up as much space as your parent allows you to. And there's also wrap content, which means just enough to display the content plus the padding, so sort of the minimum sizing. Now when it comes to the drawable content of a widget, it can also have something called padding, which is empty pixels along its top, left, bottom, or right edges. So when a widget is laid out, and really when a group of widgets is laid out within a view group, it's laid out in two passes. First, there's a pass called the measure pass that computes the dimensions of the children widgets, and there's a layout pass that computes their positions. Now, an application developer can also assign margins to a view group, which is space that is outside of the drawable region of the widget. There's a class called margin layout params that specify the margins with using various properties. So if you want to have the same margin on all four sides of a widget, you just use the margin property. But you can also specify just the margin for the left or the margin for the top and bottom with margin vertical. Now let's talk about some of the different kinds of layouts. A linear layout is a view group that arranges its children in a single row or a single column, depending on the value of the orientation attribute. The linear layout will respect the margins between the children widgets and also their gravity, their horizontal alignment. It can also specify the weight for its children that influences how much of the screen individual widgets occupy. That configuration is specified by a subclass of layout params that have gravity and weight properties. A relative layout view group lays out its children relative to each other. And this is controlled by the layout params of relative layout. So the above method positions one child above another child, and there are properties like align left, align parent top, and to right of that you can use to very specifically specify the relationship among the various child widgets. So far, the widgets that we've talked about have been rather static in nature. Sure, you can set the text of a button or of a label, but if you're looking to model really complex and dynamic data, the ones that we've looked at so far are pretty simplistic. Android has a view called adapter view, which adjusts its layout based on data provided by an object called an adapter. So each one of these adapter views consists of other widgets that are themselves views, and it's the responsibility of the adapter to create that widget for the particular piece of data that's being modeled. There are several implementations of the adapter that are provided with the Android SDK. There's something called an array adapter that converts objects in a list or an array into a particular view. And that's the responsibility of the getView method, which by default returns a TextView widget that simply contains the toString value of the element of the array. The simple cursor adapter is an adapter that creates view objects for each value returned by an object that's called a cursor. A cursor basically represents the results of a database query. Android applications have access to a database, a very simple relational database, that they can use to store and query information. A simple adapter gives you lots of flexibility into how your data is modeled. It's essentially backed by a list of string-keyed maps, so maps that map a string to some object, that let you bind data in your view by a property name of the objects in the map. Another nice attribute of the adapter and adapter view classes is that they can synchronize the information being displayed to the user with the underlying data objects. So if the underlying data that's associated with an adapter and being displayed in an adapter view changes, you should invoke its notify dataset changed method, and that will refresh the display. We just looked at several kinds of adapters, and here are some widgets, some adapter views that work with those adapters. There's ListView that displays a vertical list of elements from its list adapter. So this is a pretty commonly used widget. Whenever you see a list of data, it's likely a list view. There's also something called an expandable list view, which offers two levels of lists, a list of lists, and there the data is modeled by an instance of expandable list adapter. Another kind of adapter view is called a grid view, and that displays a table of widgets. And you can configure the number of columns as well as something called stretch mode on that grid view. Spinner is an adapter view that provides a drop-down menu of choices. And Stack View is an adapter view that displays its children as a stack of cards that can be scrolled through. Similarly, View Animator is an adapter view that displays only one of its children at a time and then animates displaying the subsequent children. You can configure properties of it such as auto start, in terms of whether it starts displaying the next children automatically, how long it goes between displaying children, the flip interval, things like that. Now we've seen that there's Java APIs for working with widgets and working with view groups. That's what's used to create and configure these objects. However, you can also configure your UIs declaratively in XML files that reside in the res layout directory inside your Android project. When your Android application is built, these XML files are processed into what are called resource objects. It can be referenced in your code via a global field called r.layout. Capital R stands for resource in this case. So for instance, you can have an XML file that describes your login screen in a file in the source resource layout directory named login_screen.xml, and the compiled version of that object can be accessed as r.layout.loginscreen. The layout comes from the layout directory in which the login_screen.xml file resides. The activity associated with the login screen will use the setContentView method to associate the activity with the view. All of that will happen in the activity's onCreate method. Now I recommend that you use XML to declare as much of your application layout as possible. It's less verbose than Java, and the tools support it really well. This XML file describes views. Very often the root XML element will be a view group that contains one or more views. This is the layout of your screen. The properties of the UI objects, the views and the view groups, are configured as XML attributes. Everything corresponds to the Java API. There is some special nomenclature, though, that you need to be aware of. The ID property of a widget should begin with the @+ID to indicate that a new object should be created when the XML is parsed. If you have a property that references another object, its value should begin with @ID. Let's say you're declaring a view that resides within some view group. There could be properties of that view that actually apply to the view group in which it resides. In that case, you want to prefix those properties with layout underbar. So you'll see things like layout underbar width and layout underbar height. There's also an include tag that you can use to include other resource files into this XML file. So while you can use resource files to declaratively configure your UI layouts, Android applications can declare other resources to be compiled and made accessible via the R object. So resource files in the res color directory describe colors for an item in various states. So think about a button or a checkbox that can be pressed, focused, checked, etc. As we mentioned, res drawable contains image files, vector graphic files, etc. get compiled into things that are displayed, drawed, on the screen. Res layout contains UI layouts. You can configure application menus in res menu. If you have raw binary files that don't need to be compiled, you can place those in the res raw directory. I'm thinking things like maybe MP3s, so videos or sound files that you want to deploy with your application. Of course, you should think long and hard about how many and what kind of binary files you want to include in your application, because it'll just make your overall application larger. There's a directory called res values that contains various kinds of data. Strings, integers, colors, application configuration information, things like that. And finally, if you have some XML data for your application, that can reside in res XML. And again, the reason for this format is that the Android compiler, the Android build system, treats each one of these directories specially and will interpret the resource files in these directories appropriately and in many cases make it available via the R object in your code. Taking a closer look now at the XML files in the res values directory, these files define resources that contain things like strings that have a name and a value. So this is a display string or configuration string for your application. These strings are available to your code via the context object by invoking its getString method or getText method. Another type of resource is a string array, which is multiple strings. The string array itself has a name, and then it has child item elements that are accessible via called getResources.getStringArray. The plurals resource allows for pluralization of display strings. So here, when you get the resources, you specify what string you want and also what quantity of data is being displayed. Because these resource files are XML, they'll need to escape or especially handle special characters like add and question mark, greater than, less than, ampersand, all that good stuff. These resource files also have built-in support for formatting that allows you to use facilities similar to Java's string formatting, using %d, etc. So we've learned about views, which are widgets. We've learned about view groups, which lay out widgets in a certain way. And we've learned how to configure UIs using XML files. What happens when the user interacts with your application? Well, this user interaction triggers something called an event. And your application can listen for those events and respond accordingly. Now, a listener is an object. And it's not so much an object that has state, but it's an object that has behavior. And so different kind of views provide interfaces that consist of methods that are invoked by the widget when a particular interaction occurs. And in almost all cases, that interaction is represented as an object that's delivered to the listener's method. So for instance, when a view is clicked, the onClick method of the onClick listener that is associated with that widget is invoked. In Java, listeners are often implemented as anonymous inner classes that extend the listener interface and provide the behavior desired by the application. Most listener methods have a void return type, but some have a boolean to indicate that the event has been consumed and should not be processed further by other listeners. So much like with a web application that just sort of sits there until a request comes in, user interaction can occur at any time. And note that the listeners are invoked inside the main application thread. This is the same thread that renders the UI. So when responding to an event, your response should be quick. Don't do things like go and download a bunch of information or do a lot of intensive computation, because otherwise your application will be slow or laggy or appear to be unresponsive. All views support a couple of kinds of listeners, and you can register the listener using methods like setOnClickListener. These callback methods all receive the view object that's being interacted with. And this can be quite convenient if you then want to set some state on the view in response to the event. So let's look at some of these callback methods. The onClick method of onClickListener is called when the user touches the widget or when the enter key is pressed. OnLongClick, which is on a different listener interface, the onLongClickListener, is called when the user taps and holds the widget. All views also have an onFocusChange listener, whose onFocusChange method is invoked when the widget gains or loses input focus. So think of a text field, I guess, or even a button can get the input focus. If your Android device has a physical hardware keyboard, then the widgets will receive on-key events when a key is pressed. Note that software keyboards, which are common on phones, don't trigger this event. And when any touch movement occurs within the widget, the onTouch method of an onTouch listener is invoked, with some information described in an object called a motion event, which tells you what kind of motion has just taken place.